The standard form of linear equation in two variables is in the form of ax plus by is equal to c. Since this is a linear equation in two variables, that means those variables must have the exponent which is 1. When you see that there's no exponent written, it is understood that the exponent is 1. The exponent of the variable is 1, basing from the um, power of 1 for the exponent rule, that any number raised to 1 is equal to the number itself. Okay, so here, for the linear equation, once again, the exponent of the variable, in this case we have x and y, the exponent must be 1. Okay, so the the variable x must be the first term, and then followed by the variable y, and then here, on the right side of the equation would be the constant term. So here, a is the numerical coefficient of the variable x, b is the numerical coefficient of variable y, and c is the constant term. For example, we have 2x plus 4y is equal to 5. Okay, so a here is 2, so this is 2, this is a, which is the numerical coefficient of the variable x, and then we have here 4 as your b, and then this one is the constant term. That means it has no variable. Okay, so this is c. Okay, but not all linear equation in two variables are written in the standard form. Okay, so this is the standard form, so you must take note of this once again. If it is not in this form, therefore it is not in standard form. Okay, so but before that, we have to take consideration in recalling some topics that would help you convert any linear equation into variables into the standard form, such as this one. Okay, so what are those? We have here first the additive inverse property. That means the additive inverse here means their signs are opposite. Just like this one, we have a, you're going to add its opposite, which is negative a. It is always equal to 0. So any number with opposite signs, when you add them, it is always equal to 0. Okay, so like for example, we have negative 2 plus positive 2. Okay, so this is equal to 0 because you are adding a negative 2 to its opposite sign, which is positive 2, then it will be equal to 0. Okay. Next, we have the additive identity property, which states that the sum of any number and 0 is equal to the given number. Okay, so 0 is actually the additive identity. So any number added to 0 is equal to the number itself. For example, 10 plus 0, it is equal to the number itself, which is 10. Okay, because 0 is the additive uh, identity. Now for the multiplicative inverse property, inverse, that means you're going to have the uh, inverse of a number. Okay, so a whole number has, any whole number has always a denominator which is 1. So the inverse would be the denominator will become the numerator, and the numerator, which is a, will become the denominator. So therefore, the additive inverse of a, or the whole number a, is equal to 1 over a. Okay, so that means if you're going to multiply the multiplicative inverse of a number, it is always equal to 1. Okay, so for example, you have 1/2. If you're going to multiply it to its multiplicative inverse, to its inverse, which is 2 over 1, or just simply the whole number 2, it is always equal to 1. As you can see, when we are multiplying fractions, we are multiplying numerator to numerator, denominator to denominator. So that means 1 times 2 is 2, and 2 times 1 is 2. And any number divided by itself is always equal to 1. Okay, so that is the multiplicative inverse property. Now we have the multiplicative identity. If here in the addition identity we have 0, in multiplicative identity it is 1. That means any number multiplied to 1 is equal to the number itself. In the additive inverse, any number added to 0, since it is additive identity, uh, it is always equal to the number itself. Here, in the multiplicative identity, any number multiplied to 1, because 1 is the multiplicative identity. Any number multiplied to the multiplicative identity, which is 1, is always equal to the number itself. So, for example, 10 times 1 is equal to 10, equal to the number itself. Okay, lastly, we have the commutative property of addition. Here, since addition is involved, it says here that the order of the addends does not affect the sum. The value is still the same. So, for example, 1 plus 2, it is equal to 3. And if you're going to change the order of the addends, for example, 2 plus 1, it is still equal to 3. Okay, so let's look at this. Let's try to see which property we're going to use in order to have the missing term. Okay, it says here 4 plus is equal to 0. So in order to make it equal to 0, you have to add it to the opposite sign, which is negative 4. And by using the additive inverse property. Okay, so additive inverse, it means the opposite signs of those number. Okay, so 1 is 4, positive 4, adding it to negative 4. Now, look at here for the second one. We have blank plus 3x is equal to 3x. So what number must be added in order for 3x to be equal to itself, to the also to 3x? So we're going to use the additive identity. Okay, we are going to add 0 because 0 is the additive identity. So this is additive identity property. Okay, property. Since 0 is the additive identity, therefore the missing term would be 0. Okay, how about here? We have 2x plus 3y is equal to 3y plus. Using the commutative property, which means the order of the addends does not affect the value of the equation. So we can put the missing term here as 2x using the commutative property. Okay, next, here, what is involved here? Of course, multiplication. Okay, what must we multiply uh, a number to be multiplied to 5 in order for it to be equal to 5 also? Okay, so what is the number wherein if you're going to multiply to a number will be equal to the number itself? Of course, it is 1. Based from the multiplicative identity property, because the multiplicative identity is 1. That means any number multiplied to 1 is equal to the number itself. So this is multiplicative identity. Okay, identity property. Okay. Next, the last one. As you can see, what are you going to multiply here in order for you to get x? Okay, so this means that you have to multiply this by using the multiplicative inverse. Okay, so you're going to uh, multiply the inverse of this one to make this one, and then you're going to use the multiplicative identity. Okay, so what is the multiplicative inverse of 7? So 7 or any whole number, the multiplicative inverse would be the 1 over 7. Okay? So we're going to multiply here 1 over 7, because if you're going to multiply 1 over 7 to 7, this will be equal to 1. And then if you're going to multiply to x, the x will remain. So we have two properties that we have used here. So I'm going to put 1 over 7. First is that I use the multiplicative inverse. Okay, in order for me to get uh, to get to get 1 as one of the factor that are going to multiply to x to make this x itself. So 1 is multiplicative inverse, inverse first. So I multiply it to its inverse to make it 1, and then multiplying it to x. That means we also use the multiplicative identity, because 1 is the multiplicative identity. Okay, so that's it. Um, let's see. Since you already know these properties, let's try to convert those linear equation with two variables into a standard form. Okay, once again, what is the standard form? It should be in ax plus by is equal to c. Okay, so the x first would come first, and then second one is the one which has the y variable and then the constant term. Okay, we have here 4y is equal to 6 minus 5x. This is a linear equation because the exponent of each variable is 1. Although, however, this is not in the standard form of linear equation in two variables. Okay, so what are we going to do? Let's convert this to the standard form. This should comes first here on the left side of the equation. So let's put it here. 4y is equal to 6 minus 5x. Okay, we have to convert this into the standard form of quadratic equation, which is ax plus by equal to c. Okay, so that means in the right side of the equation, only the constant term will remain. So the constant term here is 6. It has no variable, so it will be on the right side of the equation. But how are we going to put this here? So since this is minus 5x, I'm going to add something to make this 0. Okay, so using the additive inverse property, so that means you're going to add to the opposite of this one. Since this is minus 5x, we're going to add positive 5x to make this 0. And then we have here 4y. Since you added 5x here, of course you must also add 5x to the other side of the equation. okay? In order for you to not to hurt the value. Isn't it that if you're going to add, for example, we have 3 is equal to 3. Now, if you're going to add 1 here, this will not be equal or anymore. So what you have to do is you must also add 1 on the other side so that the value would be the same. Okay, so 3 plus 4 is 3 plus 1 is equal to 4. Same here, it is equal to 4. So therefore, it won't hurt the value. They are still equal. Okay, so same thing here. Uh, up to whatever you're going to add here, you must also add it to the other side of the equation. Okay, so we have now 4y plus 5x is equal to 6 minus 5 negative 5x plus 5x will become 0. Okay, so the equation will become 4y plus 5x is equal to 6. But take note, the x here must be the first term. Look at this. The x must be always on the first term. So therefore, you're going to put 5x and then plus 4y is equal to 6 using the commutative property of addition. Okay, so uh, meaning even if you change the order of the addends, it is still the same. Like for example, 1 plus 2 is equal to 3. It is also the same as 2 plus 1 is equal to 3. So here, 4y plus 5x is also the same as 5x plus 4y. Okay, so that's it. We already have the standard form. Okay, so this is the standard form where your a is equal to 5 because 5 is the numerical coefficient of x, and then your b is equal to 4 because 4 is the numerical coefficient of y, and lastly your c, which is the constant term, is 6. Okay, now looking at this equation, let's try to get the possible values of the two variables to make this an equation true. Okay, so we have 5x. Let's put it here. Write this here. 5x plus 4y is equal to c is equal to 6. Okay. What are the possible values of x and y to make this equation true? Linear equation into variables true. Okay. Let's start with assigning the values of x and y. Let's use a table. So here are the table values, the possible values of x and then for y. Okay, this is x and y. Okay, so if x is 0, what's going to be the value of y? All you have to do is just simply substitute x is equal to 0 to the equation 5x plus 4y. Okay, so we have 5x plus 4y is equal to 6. Okay, so let's substitute x as 0 because we put it here 0. So 5 times 0 plus 4y is equal to 6. Okay, so any number. So this is the uh, multiplicative. Any number uh, multiplied to 0 would be equal to 0. Okay, so 0 property of equality. So we have here, we can cancel this out now. So what we have is 4y is equal to 6. Y therefore is equal, so we have to divide both sides by 4. Okay, because or multiplying both sides by the multiplicative inverse of 4 to make this 1. Okay, so the multiplicative inverse of 4 is 1 over 4. So if we're going to multiply it here, we must also multiply it to the other side of the equation so it won't hurt the value of the equation. So you can cancel this out now. This becomes 1 because 1 times y would be equal to y. And then 6 times 1 fourth is, yeah, 6 times 1 fourth is equal to 6 over 4. And reducing this to the lowest term would be 3 over 2 because they are both divisible by 2. So we have to divide the numerator by 2 or just simply factor them. That is the different ways of simplifying a fraction. You can multiply this by 2 times 3, and this is 2 times 2. Okay, just cancel out 2 over 2 because 2 over 2 is equal to 1. So what's left is 3 over 2. So therefore, if your x is 0, your y would be 3 over 2 or 1 and a half. Okay, what if x is 1? Okay, what if x is 1? So if x is 1, just simply substitute x as 1. 5 times 1 is equal to 4y. I'm sorry, plus 4y. So that's plus 4y is equal to 6. Okay, so any number multiplied to 1 will be equal to the number itself by multiplicative identity property. So this is 5 plus 4y is equal to 6. Okay, I have to get the value of y, so I have to make this, uh, we have to make sure that this will be transferred here by just using the additive inverse. So we're going to add the opposite sign of this. So we have 5 plus negative 5 and then plus 4y is equal to 6 plus, so as I've said a while ago, if you're going to add something here, you must also add it to the other side of the equation, uh, which is negative 5. Okay, so we can cancel this now because this one will become 0. So 4y therefore is equal to 6 plus negative 5 is adding on like signs will give you would mean you're going to subtract and get the sign of the bigger number, and the bigger number is positive and 6 minus 5 is 1. Okay, so y therefore is equal to 1 over 4 by dividing both sides by 4. Okay, we have, or same as this one, you're going to multiply it to this in the inverse of this. So we have 1 over 4, the multiplicative inverse property. So we're going to also multiply here 1 over 4. Okay, so cancel this out. This becomes 1 based from the multiplicative identity property. So this is y is equal to 1 times 1 fourth is 1 fourth. Any number multiplied to 1 is equal to the number itself, which is 1 fourth. Okay, y therefore here is 1 fourth when your x is 1. Okay, how about if your x is negative 1? Okay, so instead of positive 1, let's make this negative 1. So therefore this becomes negative. Okay, let's erase this first. Okay, let's have 2. What if positive 2? I'm going to use positive, still positive. How about if x is positive 2? What is your y? So once again, we're going to substitute x as 2 and then plus 4y is equal to 6. Okay, so this is 10. 5 times 2 is 10 plus 4y is equal to 6. So once again, uh, make this 0. So you have to add the opposite sign of this, which is negative 10. So 10 plus negative 10. Okay, since you are adding negative 10 here, of course, you have to add negative 10 also here, plus negative 10. Okay, so let's put the 4y here, plus 4y. So this is would become 0. Okay, so 4y therefore is equal to, you're adding unlike signs. That means you have to subtract and get the sign of the bigger number. The bigger number is negative, and you have to subtract them. So this is negative 4. Y therefore, so we're going to, once again, multiply the multiplicative inverse here to make this 1. So 1 over 4 is the multiplicative inverse. But we must also multiply 1 over 4 here to it in order for the equation not to be hurt. Okay, so we can cancel this now. What's left is y, and negative 4 multiplied to so 4. So this is you're multiplying negative to positive, it will become negative. And then 4 times 1/4, you are actually multiplying the multiplicative inverse. Okay, so this would be equal to 1. So y therefore is equal to negative 1. Now, how are we going to put this? How are we going to graph this? We're going to continue discussing about graphing, but let's try to graph this here briefly. So x is 0. This one. This is 0. And your y is 3 over 2 or 1 and a half. So where is 1 and a half? Positive. This is 1 and 1/2. Okay. No, it's the y is 1 and a half. So y is here, on the y-axis. So we have 1 and 1/2 here. Okay, so this is the one of the point. And then how about the second point? We have x is 1 and y is 1/4. Okay, so x is 1, so this is x, and y is 1/4. If this is 1/2, this is 1/4. Okay, so this is the second point. And then next, if your x is 2, your y is negative 1. Okay, so your x is 2, positive 2. Your y is negative 1. Okay, so x is positive 2, y is negative 1. So here is the uh, point. So we have 3 points here plotted. And if you're going to connect all the points here, you're going to form the graph of the linear equation in two variables. So therefore, this one is the graph of 5x plus 4y is equal to 6. Okay. So next time I'm going to show you on how to graph linear equation uh, by using the y-intercept form of the equation. This one we used to graph the linear equation to variables using the table of values. This one, in order for us to get the graph. It is a line since this is a linear equation into variables. But next time I'm going to teach you on how to graph linear equations using the slope intercept form. Okay.